for joining us today. My name is Victoria and I'm a Senior Business Development Coordinator at 2H Offshore. This is our first webinar of 2022 and our third year bringing these webinars to you. Thank you for your participation in our virtual events the last couple of years. We hope you continue to enjoy the content each month. Our webinar today is entitled Exploring Jacket Platform Wellbay Expansion Opportunities. Before we get started, I'd like to cover a few important housekeeping items. Firstly, this webinar is being recorded and it will be made available to you soon, so please look out for a link to that in your email. Secondly, if you have technical or content-related questions today, please feel free to ask them at any time. You can use the Q&A box that is located on the right-hand side of your screen. At the end of the presentation, we'll go through as many questions as we can, but if you have further questions, feel free to contact our speaker directly after the presentation. And with that, I'm very happy to introduce our speaker today, Ben Andrew. Ben is a director at 2H with over 16 years of specialist engineering experience in design, analysis, and delivery of offshore structures for oil and gas and renewables markets. He has held project management and technical lead roles on projects from concept through to detailed design based out of London, Leiden, Houston, and Kuala Lumpur. He's currently responsible for 2H's fixed offshore wind and platform engineering business for our UK office. So with that, I'm going to pass things over to Ben to get us started today.
Thank you, Vic. Also apologies to anybody who was expecting to attend this 2 weeks ago. Unfortunately, I had to postpone things due to a last-minute business trip, but we've made it today at least, so that's good. So yes, today I'm going to talk about why we might want to look at Wellbay extension as a solution for platform expansion, essentially. I'll talk a little bit about the motivations behind that and why we'd be interested in doing it. And then I'll give a bit of an overview of different types of Wellbay expansion that one might want to look at as a solution to that problem. In particular, I'll focus on one particular case study that just illustrates what can be done in a fairly sort of cheap and effective way, and then a few summary and concluding remarks at the end. And as Vic says, there'll be time for questions. So if you do have any, please put them in the chat as we go along. So with that, I will get started with the motivations that we have for doing this. So as we're all aware, around the world, we've got many aging platforms of varying sizes and capacities in a number of very mature basins around the world. These are geographically spread, North Sea, for example, Middle East, Asia as well. And these platforms are in some cases pretty old, and in some cases still producing, in some cases only producing from some of their wells. And life extension of those platforms is a pretty attractive proposition for a number of reasons. First and foremost, maybe we delay the decommissioning of that platform, which is a significant capital outlay to decommission that infrastructure. Secondly, we may well want to keep producing product from that well as well with reduced or minimal capex. So it may not be effective or cost effective to build an entire new platform to continue tapping that prospect or maybe some remote pockets within that reservoir, but there may well still be product there that we want to produce. It also reuses less CO2 compared to a new development. A complete new build platform has quite a lot of fabrication and installation costs associated with it, but that translates into carbon budgets as well. And so expanding an existing platform can be less carbon intensive than building entirely new facilities. So fundamentally, life extension can be a pretty low cost and low carbon way of extending our production from a mature field. Our opportunities to do this are also increasing. We have much better monitoring techniques for looking at the status of a platform and its wells. We have digital technologies to help us to do that and to understand how the structure is going to change in its response both now and in the future. And we've got improved analytical methods that we can utilize to extend the structural life, which we may not have had when this structure was first designed. In many cases, structures are built to be very robust and conservative, and when you actually come back and look at them in the future, there's room to extend their life or to build additional capacity into them. And then in terms of the actual wells themselves, the directional drilling is a very mature technology today, but is nevertheless continuing to improve. And that allows us to tap pretty remote reservoir pockets from a host platform. So we don't have to go and build new platforms directly above these remote pockets. We can tap them from a distance with directional drilling technologies. Unfortunately, things are never completely simple. These opportunities can often be constrained. The existing Wellbay architecture on the platform may not well suit expansion. The existing infrastructure and facilities may have some challenges around that. And even the trajectory of the wells themselves, once we get below the seabed, either in the near field or the far field, can be a challenge that may, for example, mean you can't just recover slots from within the Wellbay. So the real question here is, how can we realize the benefit of these platform life extension opportunities when these various constraints apply? In addition to that, there's a few additional benefits. Slot recovery can be challenging. It does work very well in certain situations, but there can be challenges with it. And if you can do a Wellbay extension and avoid needing to use existing slots, that can be an easier route. In particular, you're not reusing any corroded or worn tubulars, whether they are the conductor pipes that are acting, structurally for the well or as an environmental barrier, or whether they're the tubings themselves that are the part of the existing well that you plan to sidetrack through or whatever. There may be limitations to what can be done there due to historical corrosion issues or wear issues during previous drilling and sidetrack operations. As I mentioned earlier, once you get below the mud line, there may be collision challenges between the different directionally drilled wells, particularly again if you've had a number of historical sidetrack operations or previous slot recovery operations. Whereas a Wellbay extension goes a little bit outside of all that and so can avoid at least the shallower challenges. And finally, they can have easier well access for intervention or abandonment. If you are extending a Wellbay on the side of the platform, it's easier to get over it with a jack-up rig of opportunity rather than necessarily working over the platform wells within the original infrastructure, particularly if they were originally commissioned as pre-drill wells. So those are some of the motivations. That's why we might want to do a platform or Wellbay extension. So now what we need to talk about is what those Wellbay extensions might look like. And there's a range of options as to how you may do that. So on one extreme, you've basically got build a new facility, not a full-blown standalone jacket with all its own processing capability, but a minimum facilities platform. It may be remote from the hub, it may be very close to the hub, maybe even bridge linked to the hub platform, but it's a standalone platform with its own wells and manifolding, and then an offloading back to the main host platform. Slightly more simple than that, you've got maybe a wellhead platform like I'm showing in the middle here, which is the same thing but simpler essentially. This is really just a well on a stick, but again sitting remote from the main platform, potentially with some bridge link access to it. But then getting beyond that, you get to the genuine retrofit, which is more like I'm showing on the right here. And again, they could either be self-supporting wells, essentially freestanding wells that are just adjacent to the jacket and plumbed back to the main facility, or they may be genuine retrofit wells that are supported from the platform. So there's a sort of range there, all the way from a fairly substantial minimum facilities platform, freestanding, a distance from the host facility, to just a couple of additional wells essentially strapped to the existing jacket. And these are all solutions that have been employed, and again, there's pros and cons to them. So first of all, what do I mean by these sort of standalone minimum facilities platforms? I mean, to realize the benefits that we talked about at the beginning of low cost, low capex, low CO2, they really do need to be very efficient and genuinely minimal structures and facilities. So this is where an option like a conductor supported platform can be a practical solution, or a very minimal jacket, all the way again from a very simple wellhead platform type solution, which may only have 1 to 3 wells and a single deck, and essentially all that well stream is exported via the hose to the host facility, through to a more substantial wellhead platform with a number of decks and some manifolding and flow metering, up to a more substantial full-blown minimum facilities platform. So those are the sort of standalone platform solutions to expand the capacity of an existing facility, but they are fairly substantial structures in and of themselves. The principle behind these structures is that we want them to be, we want them to be efficient structures. So we typically make use of the well conductors for strength, and I'll come back to this a little bit when we talk about the genuine Wellbay extensions. So this needs to be built on a real understanding of how the well responds and how the conductor responds, and we can utilize the sort of additional capacity, the residual capacity, if you like, of those conductors to support the structure itself. And that's the principle of a conductor supported platform. In terms of the facilities, it's very, very easy to keep adding requirements and adding scope to the facilities, and that pushes the top side up, which increases the cost, but also can threaten the solution as a whole. So the focus for the top side needs to be on a genuinely minimum facility platform architecture. So minimizing the equipment manifest, minimizing the energy consumption using all electric architecture where we can, and a genuinely no-touch philosophy so that it is really an unmanned installation with very minimal support for personnel. But maybe more important than all that is the integrated and efficient T&I. So preferably these things should be rig installed, so you're not having to mobilize heavy lift vessels to get them in the water. They can be installed by the rig that's going to drill the wells anyway, so that saves on mobilization and demobilization costs. In terms of rig installation, you get to use the vessel that's going to be there anyway to do the drilling operations. Therefore, it's you're saving on those mobilization and demobilization costs. In order to make that work, we do need to have small structures, nice compact substructures, not a large-scale jacket, of course, which is why keeping the topside facilities weight down is important. But we also want to make use of the vessels and yards of opportunity. We don't want to be shipping this platform halfway around the world. We want to build it locally in the yards that are available. That's more cost effective and again more time effective and more energy efficient. So those are the principles behind even these larger scale conductor supported platform type solutions. But they are limited in what they can do. The sweet spot really for a conductor supported platform is relatively low topside weights, certainly under 400 tons, relatively modest water depths, ideally under 55 meters. We can extend them beyond that. Benign environments, because they are freestanding structures that are relying on these unsupported conductors to give them their strength. That's only really viable in fairly benign environments. And a relatively small number of wells, but then typically for an expansion campaign, that's what you'd be looking at anyway, but say 6 wells or fewer would be standard. So if you're in this sort of region on the left here, these can be a good solution for a standalone platform to expand an existing facility. But there is actually an even more cost-effective approach, which can be to essentially just look at a genuine Wellbay expansion rather than a new Wellbay serviced by the host facility. Genuinely expand that platform's Wellbay and its conductors. But a lot of the same principles are going to apply here as applied to the conductor supported platform solution. So first of all, again, we want to make sure we're using an efficient structure for doing this. So where possible, we want to make use of the existing jacket structure that already exists. We can leverage those integrity management and life extension techniques, advanced analytics and simulation techniques that we have in order to maximize the accuracy of our assessment of the existing structure and hence take advantage of whatever residual capacity it may have in order to support the platform extension. We can also, again, like the conductor supported platform solution, make use of the well conductors as part of this. We're not just strapping wells to the jacket, we're also strapping conductors to the jacket. And those conductors themselves bring some strength and capacity with them, just as they do for the conductor supported platform solution. Again, that relies on a good understanding of conductors and the well engineering aspects of this, but it can add additional capacity almost for free because you need them anyway as part of the well construction. In terms of the facilities, again, we need that same mindset that we have for the conductor supported platforms. Here we're trying to use the existing facilities that are on the host facility, but we still want to be able to maximize or minimize our modifications to those. So for example, we want to make sure we're optimizing the deck space so that we're not congesting the platform too much. We want to make sure we're using as little power as possible, so we're not having to build more power generation onto the platform, and we're using best use of what we've already got. We want to make sure we genuinely understand the operations that the client wants to perform on that platform in terms of remote operation and shutdown to maintain a normally unmanned arrangement for that platform, potentially in terms of draining and venting of the materials and the products that are produced by the wells. And we may want to change out some of the equipment. So in some cases, it will make sense simply to use or expand the existing equipment that's on the platform. In other cases, we will want to replace that with something that's maybe more well suited to that really minimum facility architecture that can suit the existing wells and the additional wells. It's very much a case-by-case assessment because it depends how many wells are still flowing from the original facility. And those same considerations around integrated and efficient T&I are also relevant. We still would like to make this rig installable. We still want to make sure we're using very small structures where they're required, and we still want to make sure we're using vessels and yards of opportunities. So a lot of the same principles from the conductor supported platform solution translate to this Wellbay extension solution. What type of Wellbay extension do we go with? Well, it's driven by the facilities expansion that's required. For example, do we need more deck space in order to put more facilities equipment on the top side? It's driven by the well trajectories. How do we need to deviate these new wells away from whatever's going on below the mud line? And it's driven heavily by the integrity of the existing structures. To what extent can we rely upon the jacket for the additional capacity? And to what extent do we need to introduce new capacity through the additional structures that we add? So that summarizes the various different opportunities that we have or options that we have to solve this Wellbay extension problem. What I now want to talk about is just one implementation of that that we did a few years back to give an idea of exactly how that looks or can look in practice. This is by no means the only way to do this, but it's a case that worked very well in one particular circumstance, so it illustrates the point. So brief project overview. This is the platform shown on the right here that was to be expanded. They were looking to add 3 wells to this existing facility. As you can see, it's already a very minimal facility here. And we're just looking at bringing 3 new wells on stream. In order to do that, there was no slot recovery option on here. All the slots were used and all these slots were still producing. So there were no existing slots on the platform that we could add additional capacity to. And it was not economical to install a new platform. For only 3 wells with a relatively low production rate, it wasn't practical to go and put a new platform in. So that's why we ended up with the expansion plan. So what we ended up doing was putting on 3 36 by 1 inch conductors together with an extension deck to give a little bit more topside space. And those conductors and extension deck were to be installed on the platform north for 2 reasons: partly the routing of the wells and where the additional reservoir taps were going to be, but also because as you'll see in a moment, the platform north side had a straight section of jacket with the battering on the reverse side. And we were in about 50 meters water depth, which is a perfect water depth for these sorts of applications. This platform's out in Asia, Southeast Asia. So initially just conceptual study work was done to come up with an arrangement that would deliver on those objectives. So we wanted very minimal topside. So we had a couple of small decks, as you can see there, that were essentially welded onto the side of the main deck to give additional capacity. We had a conductor guard to protect the conductors from boat impact, for example. And we had a couple of conductor guides, one at the surface and one below sea level, as you can see on the right there, to centralize the conductors and give them the stability they needed during operations. So that was the initial concept. It showed that it could be delivered, gave a sort of budgetary concept for how it would work in order to move forward with the project. And then once we got into detailed design, the focus really became on not just designing conductors that would work in this arrangement, but designing conductors that would be easy to install, focused on that, efficient T&I objective that we talked about earlier. So the conductor guard and the guides were all installed above water level. You can see on the right there that all the interfaces with the jacket are in the dry. I mean, pretty close to mean water level. I think that this does submerge in HAT, but nevertheless we could get access to all of that to install those structures in the dry without divers. We eliminated the underwater clamp and the underwater guide. Again, safer operation, fewer divers needed for the project, cuts down on cost and time, also cuts down on some operational costs in terms of inspection and maintenance of those guides, clamps, centralizers, etc. And also reduced weather-dependent activities by removing those subsea operations. So that's the sort of installation focus coming in. And in order to do that, we introduced a subsea template procedure that would avoid that diver intervention, and that's this structure you can see down the bottom here that I'll talk about a little bit more in a moment. And then this whole thing was installed using the jack-up rig and a very low-spec crane barge, so no heavy lift involved in doing any of this, of course. Very small, compact structures, again focusing on those key principles of a conductor-supported platform or a Wellbay extension. So here's just some details on what it looked like. You can see here the conductor guard that essentially attached onto the existing jacket and braced round the new conductors there to protect them. You can also see the stubs there on the right, which were welded on with those doubler plates to the existing jacket structure. And then you can see here the subsea template and the conductor guide, which is the red and the green items on the left here that were essentially pre-installed in this location. You can see here the conductor guide resting on these supports with the subsea template suspended beneath. So essentially that's all the structures that there were in order to implement this solution. Compact, small, relatively easy to handle, and all installable from a jack-up rig essentially. So how do we then install it all? Well, we mobilized that conductor guide and subsea template assembly. The conductor guard and the stubs and clamps and so on were all installed onto the jacket. And then the conductor guide and the subsea template were landed on top, as you see there on the right. After that, the topside extension deck was installed to give the additional capacity for the facilities and to give access to the wellheads and trees. And that was essentially the end of phase one. That's got all the material offshore and it's all basically on the platform. It's just not in the final condition, of course, and we haven't installed the wells. So this is how it currently looks like. We've got all these structures here supported by the platform up at around about mean sea level. You can see the lifting operations being performed here from the low spec crane barge, and everything's secured. The conductor guard is all secured with 4 clamps onto the structure. Now for the next phase, this is where the jack-up rig joined the program. So the jack-up rig is arrived on station, seabed ROV survey, and then the jack-up rig positioned itself and started piling the first conductor. So the central conductor here was piled down to the seabed. This green section is still up at the top at this point, and that essentially gives the alignment, if you like, for the template at the seabed. So at that point, we could release the subsea template, the green structure, and lower it down to its final position on the seabed. That then gives guidance for the subsequent piling operations of conductors 2 and 3, or 3 and then 2 for reasons. And then, of course, the rig is on station and ready to proceed with drilling and completion operations. So we've now got all 3 of these conductors in here very quickly, and the rig can proceed straight on to drilling and completion because it's already mobilized for the previous stage of the installation. So here's the conductors being piled through. You can see them here going through the template subsea and through the guides in the dry at the top. And you can also see up the top here the additional installed topside that was brought on. So that summarizes the process we went through in order to basically deliver 3 additional wells, all fitted on the outside of an existing jacket, bringing 3 new wells on stream with very minimal additional structures and very limited offshore time from any dedicated vessels for that. So it can be a very cost-effective way to expand the production of that facility and bring additional wells on stream for a very low cost. So to summarize everything I've talked about today, really, Wellbay extension solutions can help realize the benefits of platform life extension. They're very cheap and cost-effective solutions when the existing infrastructure and the well arrangements constrain conventional operations, by which I mean additional slots or slot recovery operations, for example. But making them a success really depends on understanding the capacity of the facilities, how we're going to tie it in, how we're going to manage electrical consumption, how we're going to control the new facilities. Platform integrity, what that platform can accommodate and what it can't accommodate in terms of additional structures and additional loads. And installation efficiency, because you could very quickly ruin all the savings you've made on the structural design if it's a very long offshore installation campaign. So pulling together those 3 capabilities of the facilities, the platform and the installation and the integrity side of it in order to deliver a real cost-effective solution for platform expansion. So that's the end of the slides there. Were there any questions?
Yes. Let me get started. Let me see the first one. Okay. First one. Okay. How do you decide whether to support the new wells from the platform or to make them stand alone? And why would you not support them from the platform?
Yeah, so I think it really comes down to the fact that the platform may have limited capacity. Another example is the one I showed here didn't have any battering on the platform on the side where we were putting the expansion. What that means is that it was relatively easy to fit some wells in with some structures there. If you did have a batter on the platform and therefore the wells had to stand further away, bracing it back to the platform can be more challenging. You might want it to stand more freely on the conductors themselves, more like a conductor supported platform arrangement. If you do that, then you can still support that structure from the main rig, from the main platform, but maybe you only do it at the topside elevation, for example, rather than trying to support it throughout the water column. That might mean you need a larger substructure, but it's it's a case-by-case assessment. But really, the reason not to do it, I think, the reason not to do it would be either that there's insufficient capacity in the platform, or that in order to support the topsides or the additional topsides or to support the wells, you need to take some of that weight on the conductors themselves.
Okay, thanks, Men. Next one, let me see. What is the risk of boat impact for retrofit wells, and how can this be mitigated?
So, yeah, I mean, when we design our conductor-supported platforms, we consider boat impact there as well. But the thing with a conductor-supported platform is that it's a fairly compliant structure. So if a boat impacts a conductor-supported platform, the whole platform can move a little bit to absorb some of that energy from the boat impact, which actually helps to reduce the level of denting that you might see in the conductors. So when we design a conductor-supported platform, we don't normally include much in the way of boat impact protection because there's enough compliancy in the structure itself. Now, that's not true for a system like this because the jacket itself is probably quite stiff and rigid, which does increase the risk of denting the wells. So that's why in the case study I showed here, there's a fairly substantial well protection structure that was fabricated as well to protect those conductors from the boat impact. The other thing to say is often we use larger sizes of conductors here, maybe 36-inch, for example, partly to give additional strength and stability to the system, but also it does mean you've got a bit more clearance between the conductor and the well. So if you do get a boat impact impinging on the conductor, there's a bit more capacity for denting before you actually start to threaten the well tubulars.
Okay, thank you. Next one is, can we equip the well extension with conductor sharing wellheads?
Yeah, I mean, I guess by not quite sure on the term conductor sharing wellheads. I mean, if we mean sort of splitter wells, for example, or dual completion type arrangements, I mean, yes, absolutely. We do them on our conductor supported platforms sometimes. There's no reason you can't do that. And indeed, then you could get from, say, 3 additional wells, like I showed here, to maybe 6 additional completion strings by the same with the same amount of structure, essentially. Of course, you add a bit more weight and so on, but that's just part of the design process. So yes, in terms of splitter wells and dual completions, you can absolutely do that.
Great. Okay, next one. Can you talk about slot recovery options, i.e. not retrofit?
Yes, so we actually we do a bit of work with one of our sister companies, Claxton, here at 2H. They do quite a lot of work providing services around slot recovery, so whip stocks and piling operations. We've looked at doing, there's a few different ways you can do that. You can either do that essentially below your lowermost guide, so you can fit a whip stock in below the mud line and deviate off that. You can fit a whip stock further up within the structure, but then you maybe need to remove guides or at least remove centralizers in order to handle that. So there's definitely plenty of options around how you do that. And then, of course, you've got just recompleting or sidetracking an existing well. So there's quite a few options with different levels of complexity. And I think the decisions between that are really around the well architecture, whether you're able to sidetrack an existing well, whether you need very much a clean, genuine slot recovery with a new conductor in there, which might be driven by the integrity and corrosion levels on the existing wells or the wear levels. So that's something we look at quite a bit to understand which of those options for recovering a slot makes the most sense for a given application, looking both at the well architecture and at the structural arrangement of the platform and the conductors within it.
Okay, thank you. Next one, how does the life expectancy of the conductors affect the design?
Yeah, so I mean, if we're using the conductors themselves to help support the additional structure, then it's absolutely critical that we understand the life expectancy of the conductors, and that's no different again to how we do the conductor supported platforms. So when we look at the conductors being part of the strength of the platform, as we do on a conductor supported platform, or as we would do on some of these platform extensions. Thinking about the life of those conductors is absolutely integral to the design. And actually, for the conductor supported platform solutions I showed, the size of the structures is actually almost always driven by managing the fatigue life of the conductors themselves. So it's exactly a translation of that same philosophy from the conductor supported platform solution to the Wellbay extension solution, that we need to make sure those conductors are fit for the life of the platform in the same way any other structural tubular member would be in a jacket, for example. And I guess one of the key aspects to that is thinking about what the right makeup solution is for those conductors. So some parts of the world they like to weld them, in which case you've got a certain fatigue life for that. But often the best solution is to use a threaded connector, in which case it does need to be a premium fatigue resistant connector to at least some extent in order to keep the structure small.
Okay, we have a couple more. What design approach would you suggest for an extension on an old platform with uncertain strength and or fatigue capacity to take the lateral loads of extension conductors?
Yeah, so I mean, I think similar to the earlier question, if there's concerns over the capacity of the platform itself to support those loads, you want to start looking at a standalone platform of some sort. Now, whether that be a fully blown conductor supported platform that could be bridge linked or could be more remote, or whether that is a Wellbay extension platform, but where the new facilities and the wells themselves are all supported by the conductors themselves, like a little mini conductor supported platform. Either of those solutions can work, but if you're really worried about the state of the existing infrastructure, that freestanding independent solution is the way to go, I think.
Okay, I think we have one more. So yeah, if anyone else has any questions, feel free to send them in. We have a little bit more time, but I'll go with this one. How does a dry tree well extension fare in comparison to a subsea tieback?
Yes, okay. I mean, I think this is a topic that's been debated for a long time. The advantage with a subsea tieback, of course, is you don't have any of this infrastructure in terms of structures and installation complexity, which is good. But that subsea well itself is typically more expensive in terms of the subsea infrastructure, in terms of the umbilicals and flow lines that are needed to interface with it. And potentially in terms of the integrity management and sort of workover operations in the future as well, where everything is subsea, so it's harder to get at. The dry tree solution, by comparison, the trees themselves are cheaper, the maintenance is easier, the workover is easier, but the downside is you then start to need these structures, and again, that's why we try and focus on keeping those structures as minimum and as easy to install as we possibly can in order to minimize those downsides. So it's quite hard to compare. I mean, really, and it can be very regionally dependent as well, because it really depends on what infrastructure you have around and how the relative costs of building that structure are compared with installing a more expensive subsea tree with all the umbilicals and pipelines required to access that. One of the nice things about actually either a CSP, conductor supported platform type solution, or a platform extension approach, is that you get all the benefits of that dry tree, easy to maintain, easy to work over solution, without all the costs of having to install a large structure to support them.
Okay, we have another one. Have the conductors been tested in different offshore environments, and what are the early learnings from those different environments?
So I guess it depends. I'm assuming by environments there we mean the in terms of the sort of severity of the environments, for example. So conductor supported platforms are most commonly used in the Middle East, in Southeast Asia, and in West Africa. So they're regions which are reasonably benign from at least a fatigue perspective. And actually coming back to the earlier question about the life expectancy of the conductors themselves, the fatigue performance of the conductors is often what designs drives the design of the substructures, and hence the fatigue environment is really the most critical. They can be designed to cope with fairly extreme events, typhoons, for example, in Asia. We've looked at applications to use them even in the Gulf or the US. Because again, the fatigue environment's actually not too bad. I mean, the hurricanes sound bad, but they're the extreme side, not the fatigue side. So it's not obvious that it wouldn't work. North Sea is more challenging, because in the North Sea you do have just continually horrible weather, as far as I can tell. So the fatigue regime is challenging for North Sea applications. It's not necessarily the case that those same challenges translate across to the Wellbay extension options, because in particular the Wellbay extension option, you're supporting the top side from the host facility to at least some extent. You may be supporting the wells at a number of elevations throughout their depth as well, which can increase the capacity of the system and may mean that in at least the more benign parts of the North Sea, the conductor extension option is actually very viable. We've done some initial studies looking at that, and we believe it is. I hope that answers the question.
Yes, I think that's great. And I think, yeah, that was our last question. So, so thank you, Ben, for all the information on the topic. And that's all the time we have for today. But as we mentioned earlier, if we didn't get your question, or if you think of more or want to continue the discussion, you can contact Ben directly using the details provided here. And thank you to our audience for your time and participation. We hope you all found this useful and will join us for more webinars in this series happening monthly. You can check out the 2H's LinkedIn page for more details and to sign up. And again, please look out for the recording of the webinar in your email in the next 24 hours. And we hope you all enjoy the rest of your day. And thank you.
Thank you, everybody. Thanks, Vic. Thanks for your questions.